As the name suggests, Sam is big. One of the largest terrestrial snails in the world, in fact.
They poke their head out and foot out.
A shell that big would completely obscure my whole head.
For years, invasive species have been framed as a slow-moving environmental problem. Something gradual, something manageable. A concern for scientists, farmers, and policymakers, but rarely a threat that feels immediate. That perception collapses the moment you encounter one of them in person. Late at night in parts of Florida, residents have opened their doors to find enormous snails gliding across driveways and garden walls. Not the small garden snails most people recognize, but creatures as large as a human fist, their bodies stretching across concrete, their shells heavy, ridged, and unmistakably out of place. In Pacific Island forests and Southeast Asian wetlands, similar scenes have played out for decades, quietly, relentlessly, and with devastating consequences. These are not harmless pests. They are among the most destructive invasive organisms on the planet. And once they arrive, ecosystems may never fully recover. The story of the world's most destructive snails does not begin with malice or intention. It begins with human curiosity, convenience, and global movement. The giant African land snail, scientifically known as Lysochatina fulica, is native to East Africa. For thousands of years, it existed there as part of a balanced ecosystem, controlled by predators, climate, and competition. That balance ended the moment humans intervened. Over the last century, this species was carried, sometimes deliberately, sometimes accidentally, across oceans and continents. In some cases, the snails were imported as exotic pets. In others, they were brought in as a potential food source. Eggs and juveniles clung unnoticed to shipping containers, cargo plants, and soil. Global trade turned a slow-moving mollusk into a globe-trotting invader. The first recorded introduction into the United States occurred in Hawaii in 1936. From there, the species reached mainland Florida by 1966. One outbreak was traced to a single act, a child releasing pet snails into the wild. That small decision triggered a 7-year eradication effort costing more than $1 million. Similar patterns repeated across the world. After World War II, giant African land snails appeared in Pacific Islands, including Tahiti by 1967, where they were introduced for food farming. The plan failed. The snails thrived, multiplied, and escaped. Southeast Asia faced a parallel disaster in the 1980s with a different species. The golden apple snail, Pomaceae canaliculata, imported from South America for aquariums and protein farming. When demand collapsed, the snails were dumped. Within a decade, rice fields across the Philippines, Thailand, Vietnam, and surrounding regions were overrun. Once established, invasive snails transform ecosystems with startling efficiency. Giant African land snails are omnivorous on a scale few animals match. They consume more than 500 plant species. Seedlings, vines, bark, leaves, crops, ornamental plants. Almost nothing is spared. Young plants are especially vulnerable. Snails sever tender shoots before growth can begin, preventing regeneration entirely. In forests, this selective feeding alters plant composition over time. Preferred native plants vanish. Tougher, often invasive weeds replace them. Understory vegetation thins. Entire forest structures shift. Even buildings are not immune. These snails require calcium to sustain their massive shells. When natural sources are scarce, they turn to human structures, scraping plaster and stucco from walls to extract lime. In parts of Florida, residents have watched as snails slowly chewed through the exterior of their homes. The damage extends far beyond plants. Native snail species are often driven to extinction, either through competition or predation. One of the most tragic ecological disasters occurred on Pacific islands, such as Moorea. In an attempt to control giant African land snails, authorities introduced a predatory species, the rosy wolf snail. The result was catastrophic. The predator ignored the African snails and instead consumed native tree snails. Dozens of endemic species were wiped out in the wild. What began as one invasive species spiraled into a full-scale biodiversity collapse. Freshwater ecosystems suffer similarly. Golden apple snails devastate wetlands by consuming aquatic plants that filter water and stabilize ecosystems. As vegetation disappears, water becomes turbid. Algae blooms take over. Fish, amphibians, and birds lose breeding habitat. Scientists warn that some invaded wetlands have crossed ecological tipping points, entering states of irreversible decline. Invasive snails also act as vectors for disease. Both giant African land snails and apple snails carry parasites, including rat lungworm, which causes eosinophilic meningitis in humans. In regions such as China, Hawaii, and the Caribbean, people have become seriously ill or died after ingesting contaminated produce or undercooked snails. Agriculture bears the heaviest cost. Giant African land snails attack nearly every crop imaginable. Vegetables, fruits, ornamental plants, citrus trees, bananas. Entire gardens can be destroyed overnight. Florida officials describe them as among the most dangerous agricultural pests in the state. The impact in Southeast Asia is even more severe. Golden apple snails are the single most destructive pest of rice in the Philippines. In heavily infested paddies, they can destroy 100% of rice seedlings. In 1990 alone, losses were estimated between $425 million and $1.2 billion. A single apple snail can consume all new growth in a square meter of rice field in a single day. Farmers are forced to replant repeatedly or abandon fields altogether. Costs accumulate not only from lost crops, but from chemicals, labor, and long-term soil degradation. The invasion becomes a cycle of loss. Governments have fought back with unprecedented measures. Florida's response to the giant African land snail has been one of the most aggressive eradication campaigns in modern environmental history. The state has faced 3 separate invasions. The most recent, beginning in 2011, required a 10-year campaign costing $23 million. More than 168,000 snails were collected and destroyed. Teams went door to door, hand-picking snails at night. Entire neighborhoods were quarantined. Movement of soil, plants, and yard waste was restricted. Snail-sniffing dogs were trained to locate hidden individuals. Chemical molluscicides were deployed strategically. Against all odds, Florida declared the species eradicated in 2021, one of the few places on Earth to do so. Elsewhere, eradication is rarely possible. Australia has avoided establishment through extreme quarantine enforcement, destroying any snail found at ports immediately. In regions already infested, control is the only option. Communities organize mass snail hunts. Ducks are released into rice paddies to consume juveniles. Birds such as the Asian open-bill stork have adapted, increasing in number as snail predators. Chemical control remains common, but risky. Molluscicides can poison fish, birds, and humans if misused. Researchers are exploring biodegradable, plant-based alternatives and egg destruction strategies to limit reproduction. One lesson has become painfully clear. Introducing predators can make things worse. The rosy wolf snail disaster stands as a warning. Modern programs now emphasize long-term monitoring, public education, and science-based containment rather than quick fixes. The biology of these snails explains why they are so difficult to stop. They are reproductive machines. Giant African land snails are hermaphrodites. When 2 individuals mate, both lay eggs. A single snail can produce up to 1,200 eggs per year and reach reproductive maturity in as little as 5 months. Apple snails lay hundreds of bright pink eggs every few weeks, coating vegetation and structures with toxic egg masses that few predators can consume. They are also extraordinarily resilient. Giant African land snails can seal themselves inside their shells and survive up to a year without food or water. Some even exhibit rudimentary learning, avoiding poisons that fail to kill them the first time. Control methods must be lethal immediately, or they become useless. The scale of infestation can be staggering. In Florida, over 1,000 giant snails were removed from a single residential yard. In Thailand, farmers have collected over 60 kilograms of apple snails per hectare. These are not minor infestations, they are ecological invasions. The final question remains unanswered. Can ecosystems recover? In some cases, the damage is permanent. Native snail extinctions in the Pacific cannot be reversed. Lost species leave gaps that alter nutrient cycles and forest health indefinitely. Wetlands stripped of vegetation may never return to their original state. In other cases, recovery is possible, but fragile. Florida's vegetation rebounded after eradication. Rice fields can be restored with constant vigilance. Some ecosystems find new balance, but often at the cost of reduced biodiversity. Invasive snails have forced scientists to confront an uncomfortable truth. Invasive snails have forced scientists to confront an uncomfortable truth. Even the smallest organisms, when moved beyond their natural boundaries, can reshape the world. Slowly, quietly, irreversibly. And once they arrive, the clock starts ticking.